Hello and welcome to the Daily Space. My name is Dr. Pamela Gay.
And I am Eric Maddox.
And most weekdays, the CosmoQuest team is here putting science in your brain. Today, however, is for Rocket Roundup.
Let's get to it, shall we? First up, on December 8th at 0040 UTC, Lab Electron launched two more satellites for Black Sky Global's commercial imaging constellation for Launch Complex 1 at the Mahia Peninsula in New Zealand. Let's watch the launch.
7, 6, 5, 4, 3, 2, 1.
Like the last Electron launch on Data with Destiny, this was another dedicated mission for Black Sky. However, unlike the last mission, the first stage was not equipped to survive re-entry, and no attempt was made to recover it. After launch, the first stage burned nominally through engine cutoff and released the upper stages to continue in orbit. All other flight events were nominal, including fairing separation and battery swap. An hour after launch, the two satellites were successfully deployed into the target orbit. This launch, along with the previous Electron launch and the ride share on Starlink 32, means that half of Black Sky's current constellation of 12 satellites were launched over the course of about 3 weeks. These 6 satellites were commissioned into the constellation in a very short period of time, with the pair on the Starlink rideshare launch being operational in just over half a day. The full Black Sky constellation will consist of 60 satellites. From one launch which took 2 satellites into orbit to another launch which took 2 satellites into orbit and also marked a major milestone. Next up, on December 10th at 011 UTC, a Chinese Long March 4B launched the Shi-Tian-6 Group 5 satellites from the Qiuquan Satellite Launch Center in China. The satellite's mission was described as, you guessed it, space environment exploration and new technology test verification. Shi-Tian-6 satellites have been launched in pairs every 3 years since 2004. This launch marked the 400th launch of a Long March series rocket since its debut on April 24, 1970. According to the China National Space Agency, the first 100 launches took 37 years. After that, the second 100 was reached in 7, the third 100 in 4, and the final set was obtained in just 2 3/4 years. In all of those launches, 700 spacecraft have been sent into orbit. The last 100 launches includes missions like Chang'e 5, which successfully performed a lunar sample return, and Tianwen-1, China's first Mars mission. After the break, the first astronaut flight on New Shepard, a rare Proton launch, and another Chinese launch.
On December 10th at 1500 UTC, a Blue Origin New Shepard launched the NS-19 mission from their spaceport in West Texas. This was the third crewed launch of the New Shepard in 2021. Let's watch the launch.
6, 5, 4, command engine start. 2, 1.
Mission Control has confirmed New Shepard has cleared the tower and is on its way to space. We can hear it here from the desk.
On board were 6 spaceflight participants, the first time a New Shepard carried its full complement of passengers. On board were Blue Origin guests Laura Shepard Churchley, the eldest daughter of the first American astronaut, Alan Shepard, TV host Michael Strahan, and passenger passengers investment banker Lane Bess and his Twitch streamer son Cameron Bess, space investor Dylan Taylor, and finally Evan Dick, also an investor, but not of the space variety. In addition to the human passengers, this flight also had a NASA payload mounted to the propulsion module on the exterior of the New Shepard. Like on previous flights, the payload tested lunar landing sensors for future Artemis program missions. This launch was one of the last chances to earn the Federal Aviation Agency's commercial space astronaut wings. This crew, as well as 15 other qualified spaceflight participants, will be among the last to be awarded FAA commercial space astronaut wings. Effective January 1st, 2022, the FAA is discontinuing the program. Instead of being awarded wings, future eligible commercial spaceflight participants will have their names listed on the FAA website. The program was started in 2004 with the intention of promoting the industry, which was in its nascent stages at the time, by recognizing the pilots and flight crew members of commercial space vehicles. The FAA stated that with 3 commercial space companies now licensed to fly spaceflight participants, the goal has been achieved and the program is no longer needed. From a quick suborbital flight to one that lasted almost a day, next up on December 13th at 12:07 UTC, a Russian Proton Briz-M launched the Express AMU-3 and AMU-7 spacecraft into near geostationary orbit from Site 200 at the Baikonur Cosmodrome in Kazakhstan. After an incredible 18 hours of flight time and 5 burns of the Briz-M upper stage, the 2 payloads were separated into a very eccentric geostationary transfer orbit with a perigee of 18,700 kilometers and an apogee above the geostationary belt of 52,000 kilometers. This gets them closer to geostationary orbit than most launchers. Both Express AMU-3 and AMU-7 were built by Russian company ISS Pizhmeny, with communications payloads from Italian company Thales Alenia Space. According to ISS Resheshnev, Express AMU, wait, hold on, I did not say those two things the same because one was written in Cyrillic and the other was not, and I missed one of the letters. I turned it into an English letter. All right, I'm going to redo that. And I'm actually going to say things correctly. And I have no clue where the V on the end of that word came from because the V is not in the Cyrillic. And Eric's just over here smiling at me. He's like, I tried to be helpful by putting the Cyrillic, and he was, except then, like, it wasn't there twice, and so my brain went sideways. All right, here we go. I'm going to start. Sorry, Allie. After an incredible 18 hours of flight time and 5 burns of the Briz-M upper stage, the 2 payloads were separated into a very eccentric geostationary transfer orbit with a perigee of 18,700 kilometers and an apogee above the geostationary belt of 52,000 kilometers. This gets them closer to geostationary orbit than most launchers. Both Express AMU-3 and AMU-7 were built by the Russian company ISS Resheshnev, with communications payloads from the Italian company Thales Alenia Space. According to ISS Resheshnev, Express AMU-3 and Express AMU-7 satellites will provide advanced communications, television, and radio broadcasting services for millions of users in Russia and other countries. Just like the Soyuz, the Proton is assembled horizontally. It's brought to the launch pad via a special slow-moving train where it is raised vertically into its launch mount. The advantages of this assembly method is that it requires less ground infrastructure at the pad to support the rocket and reduces processing time when actually at the pad. SpaceX's Falcon 9 also uses horizontal integration and often only needs a handful of hours at the pad before launch, occasionally rolling out on launch day, along with the Chinese Long March 2, 3, and 4 rocket families. Proton is one of the few rockets today that still uses toxic hypergolic propellants that spontaneously ignite when combined. Initial fueling of these vehicles requires workers to be in hazmat suits, but the use of the unsymmetrical dimethylhydrazine and dinitrogen tetroxide means that rockets can spend days at the pad without having fuel continually topped off. Like the Soyuz, Proton was originally designed to be an ICBM. All of these rockets are on their way to retirement, being replaced with better performing and less toxic launch vehicles like the Angara for Russia and the Long March 5, 6, and 7 families for China. Proton M also has an abysmal launch reliability rating, only 90%. This is another reason why it is being retired. Our next launch is another one of those pretty but deadly hypergolic rockets.
Finally, on December 13th at 1609 UTC, a Chinese Long March 3B launched the Tianlian 2-02 satellite from the Qiuquan Satellite Launch Center in China. Let's watch the launch. The Chinese were unusually candid about what this satellite's purpose is compared to what they say about, for example, the Yaogan series. The China National Space Agency stated that it was a communications relay satellite which will be used to send back data from crewed spacecraft, other satellites in low and medium orbits, and from their Tiangong space station. It has a secondary objective of downlinking telemetry from launching rockets. After the break, learn about the last Apollo lunar landing, Apollo 17. This week in rocket history is the final Apollo lunar landing, Apollo 17. Despite being the last crewed mission to the moon, it set a few firsts. It was the first and only lunar landing to have a scientist astronaut instead of a pilot astronaut with some geological training. It was also the only night launch of Saturn V. The Apollo 17 crew was chosen in 1969 and was originally supposed to be Eugene Cernan, Ron Evans, and Joe Engle, all test pilot astronauts. They were selected as the backup crew for Apollo 14 and would then have been the prime crew for Apollo 17, per the pattern at the time. However, in mid-1970, Apollos 18 through 20 were cancelled because of budget cuts and the lack of a landing on Apollo 13. Scientists really wanted a trained geologist on an Apollo flight. In order for this to happen, NASA changed the crew assignment for Apollo 17 so that scientist astronaut Jack Schmitt could fly to the moon instead of Joe Engle. Joe Engle later flew on 2 early shuttle missions and the approach and landing tests of the Space Shuttle Enterprise. So he did some cool things instead. The new backup crew consisted of lunar veterans John Young, Charles Duke, and Stuart Roosa. With the crew sorted, NASA then focused on choosing the landing site. There were many constraints on what would make an acceptable landing site, including illumination at landing, the distance from the lunar equator, and scientific merit. Remember, this wasn't just a trip to the moon to bring back science. The geologists were looking for evidence of recent volcanism and wanted to see it firsthand. Taurus Littoral, a lunar valley, was eventually chosen. The relatively flat area met the landing site criteria. As for the science, lunar landside had lunar landslides had collected rocks from different parts of the moon in one area. The valley floor was cratered from impacts, but the crater density was lower compared to the other parts of the moon. The lower crater density is evidence of volcanism, where flowing lava would have covered the missing craters before it cooled. There was just one problem with Taurus Littoral. The site of interest was smaller than the lunar module's landing accuracy. At the time, landing guidance was only guaranteed to landing in an oval 3 kilometers wide and 2 kilometers long. In order to land at Taurus Littoral, the landing guidance was adjusted to allow a 1 kilometer circle landing area. Assembly of Apollo 17 Saturn V stack started in February 1971, and by August 1971, the rocket was complete and rolled out the pad. Launch was set for December 6th, but got delayed to very early on the 7th due to an abort at T-minus 30 seconds. Launch was flawless, as were checkouts in Earth orbit and the translunar injection burn. On the way to the moon, the astronauts, probably Jack Schmitt, took the famous blue marble photograph showing the entire Earth's disk illuminated, including the South Pole, with no other Apollos had seen. The photo essentially kick-started a generation of environmentalists. Another activity during the coast phase was realigning the mission clock to the flight plan, since they had launched 2 hours and 40 minutes later than planned. This was accomplished by doing some activities earlier than planned, and then setting the clock forward the required time in one big jump, such that mission hour 65 was immediately followed by mission hour 67 and 40 minutes. Yes, NASA did something like daylight savings time, but in space. And the astronauts' sleep was not affected by this, unlike what happens to us on the ground. The rest of the coast, the moon, was accomplished without issue, and lunar orbit insertion was completed 88 hours into the mission. Powered descent was initiated 112 hours, 49 minutes, and 56 seconds into the mission. Just over 12 minutes later, at 1955 UTC on December 11th, they were safely on the moon. Only 4 hours later, they began their first EVA, which was an arduous series of scientific tasks. Ultimately, the crew would spend 3 days on the surface and do 3 EVAs, totaling 22 hours. Their very first task was setting up some experiments on the surface and using the rover to drive around and pick up samples as directed by geologist Schmitt. The surface electrical properties experiment was designed to measure the electrical conductivity of subsurface rocks. The experiment consisted of a transmitter placed on the ground, receiver antennas on both the LEM and the rover. The transmitter set signals into the surface at several different frequencies to determine what was underground, especially if there was water. The presence of water could be determined by a change in the received signal. Astronauts drove from place to place and took data, noting where they were in relation to the LEM and the transmitter at each point. At the conclusion of the mission, the data recorder was removed and brought back to Earth. Unfortunately, not much data was actually collected by the experiment because its cloth cover was knocked off and it overheated. The 2 astronauts also placed explosive charges at various points, which were later detonated after they were in orbit. The vibrations from the explosions bounced around inside the moon and were picked up by special microphones placed by the astronauts. The astronauts' EVA time was unremarkable, except for the discovery of, quote, orange soil, which turned out to be volcanic glass from previous volcanic eruptions. Impacts flip rock layers, which is what brought the volcanic glass closer to the surface. The geologists were able to determine that the impact was significant because a lot of that orange soil was present. The orange color was produced by 2 different glasses cooling at different rates. Overall, Apollo 17 taught science that the lunar mare were formed by episodic welling of lavas from under the surface, not from surface volcanic eruptions. Geologists also ruled out any evidence of young volcanic activity on the moon from the site surveyed. In the end, all the Apollo missions did was scratch the surface of how the moon formed. It's impressive that they were able to accomplish this using the limited hardware the Apollo engineers made to accomplish President Kennedy's goal of landing on the moon before 1970. After the break, we'll be back with our weekly statistics and the random space facts. Stay tuned.
To wrap things up, here's a running tally of a few spaceflight statistics for the current year. Toilets currently in space: 9. 4 installed on the International Space Station, 1 on the Crew Dragon, 1 on the Soyuz, 1 on the other Soyuz, 1 on the Shenzhou, and 1 on the Tianhe. Total 2021 orbital launch attempts so far: 132, including 9 failures. Total satellites from launches: 1,660. We keep track of orbital launches by where they launched from, also known as spaceport. Here's that breakdown. China 50, USA 42, Kazakhstan 13, Russia 9, French Guiana 6, New Zealand 6, Japan 2, India 2, Iran 1, South Korea 1. Your random space fact is that Apollo 8 astronauts took silly putty up to space with them. It kept them occupied and was also used to prevent tools from floating around. This has been The Daily Space.
You can find more information on all our stories, including images, at dailyspace.org. As always, we're here thanks to donations of people like you. If you like our content, please consider joining our Patreon at patreon.com/CosmoQuestX.